Day class. By now you probably realize that I will not be in today. We'll be conducting today's lesson using this video recording. The homework that you are to turn in today, I would like for you to please just hold on to that till tomorrow, and I will collect that from you guys tomorrow. Today's topic is going to be moving into what we call similar triangles. Keep in mind, guys, similar is not the same as congruent. With congruent, they had to be the same size and same shape. With similar triangles, they're similar if their corresponding sides are proportional and their corresponding angles are congruent. So basically, it's going to have the same shape, but they will be two different sizes. They'll be proportionally larger or proportionally smaller than each other. Okay? So there are basically three ways to show that two triangles are similar. The first way is using what's called angle-angle similarity, meaning that two angles of one triangle are congruent to two angles of the other triangle. So basically, if you can show that two angles match in each of your triangles, then that's enough to say the two triangles are similar. If you think about it, if you have two angles that are the same, automatically the third angle would be the same because the three angles have to add up to 180. And so if two angles match each other, then if you added those and subtracted them from 180, you would get the same number for both triangles. So in reality, it's angle, 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 which was, if you remember, the one test we could not use when trying to tell two triangles were congruent, because angle, angle, angle only worked for dilation. It did not work for reflection or rotation. And so this is where that comes into play. So if we have two angles, that's enough to declare two triangles similar. The next test is called side, side, side. Now, this is different from the side, side, side we used for congruent triangles. In this side, side, side similarity, we're saying that the measure of the corresponding sides of the triangles are proportional, meaning that if you write a ratio of two sides, of any two sides of the triangle, it should be the same all the way around the triangle. So it should carry that same ratio all the way around. And then the next test is your side angle side. So side angle side works, it's a combination of the two, basically saying that you're going to have two sides of the triangle that are proportional to the measure of their corresponding sides for your other triangle, and then they must include, so the included angle will be congruent. So guys, when they talk about the included angle, that means the angle that's in between the two sides that you've shown to be proportional. Okay, it can't be one of the angles outside of the two sides. It must be in between the two sides in order to use that side angle side. Okay, so let's take a look at some examples here and determine whether some of these triangles are similar or not using our three tests. Now, you'll recognize a different symbol on this paper than what we've seen in the past. You're going to see it right here. It's that sideways S. So when you see that sideways S, that's the symbol to mean similarity. Okay, just basically mean two shapes are similar to each other. So it's basically the congruent symbol minus the equal sign. So they're the same shape but not equal in size. So here we got triangle ABC similar to triangle, and we got to name it here. But before we do, let's try to figure out which test is going to tell us the two similar triangles. Again, using the markings, we should be able to name it appropriately. So if you go down here and you look at the angles, angle B, right here, 40 degrees. Come over here to the other shape, and you also have a 40-degree angle right here. So 40 degrees, 40 degrees. Now come down here, you got a 35-degree angle. And over here, you also have a 35-degree angle. So notice we have one angle the same, we have two angles the same. So if we have two angles the same, so this angle matches this one, and this angle here, so we'll call this angle 1, this will be angle number 2, matches this one here. Okay, so that's enough to call them similar by angle, angle. Alright, that first test that we talked about. Remember, if you added those together and subtracted it from 180, this angle would be the same as this one. So in reality, all three angles are the same, but it only requires two to show similarity. Now when you name it, pay attention to the angle measures. Angle A, right here, is the unmarked angle. So that's going to start with F over here. Angle B is 40 degrees. 40 degrees is L over here. And then finally C is 35 degrees, G is 35, so that's going to be G. So it's triangle FLG is similar to triangle ABC. Okay? Alright, the next one I want to look at together with you is number 4. Let's go down here to number 4. Alright, on number 4, you can see you do have a matching angle, right? You see the box, so that indicates a 90-degree angle. Alright, so that's one thing we got. Now we got to look at the sides. Now here you got a side that's 10. It kind of corresponds with this side over here that's 5. I know that it goes with the 5 and not the 4 because I have this other side down here that's 8, and 8 is smaller than 10. And those two sides make up the right angle. So these two sides make up this right angle, and 4 is smaller than 5. So 4 should go with the 8, 5 should go with the 10. So what I'm going to do here is I'm going to write two ratios. I'm going to write a ratio of 10 to 5, so those two corresponding sides, and a ratio of 8 to 4 for these two corresponding sides. If those ratios are equivalent, if they're equal to each other, and then that tells me the two sides would be proportional. Okay, so they would share the same proportionality. And so 10 over 5 and 8 over 4, if we use our cross products, like we did the other day on that assignment, you would get 10 times 4 is 40, 8 times 5 is also 40, and so that's enough for us to know these two ratios are equal to each other. So you got two corresponding sides here that are proportional. So that would be side, an angle, and a side. Okay, again, that matches up over here, SAS. So they're not saying they're congruent. This is different. This is saying they're proportional. So that ratio of 10 to 5 is the same as the ratio of 8 to 4. So we're going to say that this is side, angle, side. And they are similar. So W, and then it goes from W to Y. So W to Y is the hypotenuse. So I'm going to come over here and go M to S. And then from there to Z. So from S to K. Alright, and so WYZ, MSK. And so those two triangles are similar. Now, I want to come back over here to number 3. Let's try to do that same trick, okay? So I've got an angle again. Alright, I've got these corresponding sides, so that's a ratio of 12 over 9. But when I try to set that equal to another set of sides, which would be side LM and side TS, I can't do it. Because you notice LM has an 8, but there's nothing here for TS. TS is blank. So if there's nothing to put in here, you can't just make up your own number. It has to be provided in the drawing. So there's nothing there. So that's not enough to know if the ratio of the sides will be the same or not. So in this case, we would say LMN is not similar. Okay, because there's not enough information. It's the whole NEI, not enough information here to tell if they're similar. Okay, we'd have to know what that side is to see if that ratio is the same or not. Alright, so I'm going to ask that you guys complete numbers 2, 5, and 6. We're going to do an example like number 5 in just a moment on the back. So I want you to complete 2, 5, and 6, but wait till after we do this next example. And it should help you with number 5 there. Alright, so let's turn that over. I'm going to come up here to number 7. Alright, so guys, number 7, if you look, is drawn pretty much just like it was on the other side for number 5. So kind of pay attention to number 7 here. It's going to help you with number 5. If you have a box on your paper, go ahead and change that box. We all know now that when we see the box, that's just supposed to be parallel. For whatever reason, it just doesn't print correctly. Alright, so we have AB parallel to CD. So I'm going to come over here and mark that. So AB, I'm going to put the little arrow. And if you want to, like we always do, you can kind of extend it out so you can kind of see where your parallel lines are. And here's CD over here. Remember, the arrow does not mean congruent, it just means parallel. It's all it means. So again, I'm going to extend these sides out over here so I can really see those parallel lines. Alright, now we got to figure out why would they give us that. That's our first piece of given information, so there must be something significant about it. So think about parallel lines and what we know about parallel lines. Look for transversals. There's actually 2 transversals in this drawing. You have transversal AD. So here's AD right here. We'll call that transversal number 1. And then you have a second transversal right here, BC. So we can call that transversal number 2. Now, remember, when we have transversals, we want to look for angles and see if there's any angles that we can mark congruent based on those transversals. Usually it's alternate interior angles, but it doesn't always have to be. Sometimes it might be corresponding angles. Alright, but most of the time it will be alternate interior angles. So like on this first transversal, transversal number 1, see that letter N? Alright, here's that letter N. So there's 2 angles inside that letter N. You have this angle here. You have this angle here. So those angles are congruent because they're going to be alternate interior angles. Now, if you look at the other transversal, transversal number 2, it kind of has that same shape. Watch, I'm following the parallel line, going up the transversal, coming down this parallel line. So you can kind of see that same shape. So that makes another set of alternate interior angles right here that are congruent. Okay, so we now have 2 angles that are marked congruent. So this would be similar based on that because you have angle-angle similarity. Alright, so this drawing here has AA similarity. So now that we've established that the 2 triangles are similar, we should be able to do the rest of this problem. So it says AB equals 4. So find AB. AB is right here, and label that 4. You got AE is equal to 3x minus 4. So AE is this little piece right here, just this little short piece, and that is 3x minus 4. You got CD over here, that's 8. So CD is this side over here, so that is 8. And then you have ED. ED is this little short piece. So ED is x plus 12. Alright, and they want us to find the measure of A to E. So that's this one. They want us to find the measure of D to E. So that's this one. So in order to do that, we're going to need to know what x is, right? To be able to figure out AE and to figure out DE. So in order to do that, we're going to use a proportion. Since we know the 2 triangles are similar, then they must be proportional. So I'm going to make a ratio of my corresponding sides. So we have 4 is to 8. That's the first set of corresponding sides. And that has to equal, now notice the 3x minus 4 is off of the single arch, right? The x plus 12 is off of the single arch. So these 2 are corresponding sides. So I'm going to say it's equal to 3x minus 4 over x plus 12. Okay, so this side corresponds to this side. Now, because we can build a proportion, we can solve it for x, just like we did on that worksheet the other day. So I'm going to do my cross products. So that is going to be multiplied with this. And so you end up with 4 times parentheses x plus 12 has to equal 8 times parentheses 3x minus 4. Okay, so 4 times x plus 12, 8 times 3x minus 4. Now remember, this is distributive property. So we got to distribute here. we're also going to distribute here. So this is 4 times x is 4x, plus 4 times 12 is 48, equals 8 times 3x, which is 24x, and 8 times negative 4, which is negative 32. Alright, and so now it's just a matter of getting x by itself. So I will probably subtract the 4x on both sides. So you're left with 48 equal to 20x minus 32. Okay, I've kind of run out of room here, so I'm going to recopy this up here. So we said 48 equals 20x minus 32. So we are going to add 32 to both sides, because I moved the x to the right, moving the constant to the left. And so that's going to be 80 equals 20x. And then finally we're going to divide by 20 on both sides. And so we find that x equals 4. Alright, now be careful, don't stop there, because it didn't say find x, it said find AE and DE. So now that we know x equals 4, we can solve for AE, because it was 3x minus 4, so we're going to say 3 times 4 minus 4. So that would be 12 minus 4, so that is 8. So AE is 8. Okay, and then we'll do the same thing for DE. For DE, it's supposed to be equal to x plus 12. So I'm going to put in a 4. And so we can find out that DE is 16. Okay, now you always kind of want to check yourself, see if your answers make sense. Here, the proportional sides were 4 to 8. Notice 8 is twice as large as 4. So it should make sense that whatever you get for x plus 12 should be twice as large as whatever 3x minus 4 is. And so here we said DE was 16, AE was 8. 16 is twice as large as 8, so that does make sense. So our answer seems logical. Okay? Alright. Now I want to look at one more example with you here. We're going to look at number 8. Number 8 is going to be similar to number 6 from the front. Okay, so kind of pay attention to number 8, and that's going to help you with number 6 in the front. So on this one, I want us to name a pair of similar triangles, explain why each pair of triangles is similar, so which test are we going to use basically, and use the given information to find each missing measure. So we got to find x and y in this problem. Alright, so first we got to figure out which triangles are similar and why. Okay, so I look at my drawing here, and you see you have this big triangle here, you have this little bitty triangle here. Okay, so chances are that's probably the two triangles that I'm trying to prove similar. And you notice the first one's TUV, TUV. So more than likely I'm trying to do SUR. But I need to be able to find a reason why. So see these little parallel markings? Okay. Now those little parallel markings, just like before, if you want to, try to extend them out so you can really see those parallel lines. Alright, so there's my parallel lines right there. Remember, if you got a highlighter, you can use a highlighter or something to make them stand out. Now again, look for those transversals. Now this one's got two transversals, just like the other one did. Here's a transversal here. So we'll call him transversal number 1, T1. And there's another one right here. So we'll call him transversal number 2. So guys, talking about transversal number 1, if you look at the two parallel lines, so here's your parallel line, here's your transversal, it does not make, well, I mean, you can still see the letter Z, but that angle's outside the triangle, so that doesn't do us any good. So we don't really want to do alternate interior angles here, because one of the angles would be outside the triangle, and that's really not helpful. Okay? But look here. You do have this bottom right hand corner angle with transversal number 1, this bottom right hand corner angle, and this bottom right hand corner angle inside of the little triangle. So you do have a matching location on these two parallel lines in this transversal, one inside the little triangle, the other one inside of the big triangle. So that makes this angle congruent to this angle because those are corresponding angles, right? They're both in the bottom right hand corner of each of their respective groups. So they are corresponding, making them congruent. Now if you look at transversal number 2, you have the same situation. You can't really use alternate interior angles here because alternate interior angles don't really help you. They're ones outside of the drawing, so it doesn't really do any good. But on this one, if you look right here, this is in the bottom left hand corner of this cluster of angles up here. Okay, so it's in the bottom left hand corner. Come down here to the little triangle and you have a matching bottom left hand corner angle right here. So again, you got corresponding angles. They're both in the same location. They're both in the bottom left hand corners of their respective clusters. So with that, that's enough now that we have angle-angle similarity. Here's an A, here's an A. So you have angle-angle similarity. So that's our test we're going to use. And now we can name the triangle. So if we have TUV, so T is the double angle, U is the non-marked angle, V is the single marked. So we're going to go S for the double marked, U for the unmarked, and then way back up here to R for the single mark. So it's going to be SUR. Okay? Alright, so now we're ready to start solving. So they want us to find these couple of things here, TU, US, and TV. Alright, so you'll notice that TU is the X. So we're trying to find the X of the little bitty triangle here. Okay? So we got to think up a proportion that may help us to do that. Now where it says name the corresponding parts, this might help you to kind of visualize it if you will separate the triangles. Make your big triangle. You got R, S, and U. And then make your little bitty triangle. And you got T, V, and U down here. And so you can kind of see that VU is going to go with RU. RS will go with VT. And SU will go with TU. So when you're writing your proportions, that will help you, okay? So we're trying to find TU. That's our mystery one. So that's our X here. We know that this side over here is 3, so we can use that to help us. So find the corresponding one that goes with 3. That's RU. Well, RU is equal to 3 and 9. 9's this little piece, 3's this little piece. So RU is equal to 9 plus 3. Okay, because it's this entire segment here. And so RU is equal to 12. And then X was over here on TU, so that's matching up with SU. So SU has a 12 and an X. So SU is going to be 12 plus X. Now we can't add those together because we don't know what X is. Alright, but that should be enough to create our proportion now. So our 12 for RU goes with our 3 for VU. So we got 12 and 3. Our 12 plus X for US goes with X for UT over here. Okay, so that and that go together. Now, we've built our proportion. We can solve it using our cross products. So we had 12 times X equals 3 times 12 plus X. Okay, so 12 times X is 12X. 3 times 12 is 36. 3 times X is 3X. We'll solve this for X by subtracting 3X on both sides. So we get 9X equals 36. Divide by 9. And we get X equals 4. And in this case, X is TU, so TU is 4. Now, one of the next things it wants us to find is US. Well, guys, US was right here, right? And US was 12 plus X. Well, you already know that X is 4. So US is just going to be 12 plus 4. And so US would have to be 16. Alright, all it did is say, okay, well, here's US, 12 plus X. We already know X. X was 4. Alright, so we just plug that in and get 12 plus 4 is 16. Alright, then finally we got to find TV. Now TV, if you go back to your drawing, that's the Y up here. So that's this top piece. And so the matching would be RS, and in the drawing RS was 20. So that's going to be 20. So this is a much simpler proportion. I'm going to use the original 12 and 3 again, just like we did on the first one. You can use it as many times as you need to. And then for this other ratio, we're going to do 20 to Y. Alright, and so now we have our proportion. We can solve for Y. So you got 12 times Y equals 3 times 20. So 12Y is equal to 60. Divide by 12. And you find that Y is equal to 5. And since Y is TV, TV must be 5. Okay? And so that's how we can use similar triangles to help us find unknowns, is by building these proportions. Again, I highly would encourage you, when triangles overlap, separate them out so that you can label them separately, and it helps you to see how to build your proportions. Alright, so I want you guys to complete number 9 over here, similar to how we did number 8. Alright, and then that should conclude your assignment. I will collect this the next day, so please work on this. If you have questions, come in for tutorials the next day. Thank you very much for paying attention, and please continue to work on this till the bell rings.